Hey guys, so we're here and ready to jump into the sixth reading of Kepler's Harmonies of the World, Book 4. And like usual, I have prepared a few remarks with a few images to sort of set the tone. And even though I said last week that we wouldn't really read this particular chapter, chapter 5, because it is pretty dense and full of a lot of propositions, axioms, postulates, um, I think it's worth reading at least a few of them to get a sense of what he's doing before we jump into chapter 6. Um, and I'm gonna just show a few images here, and we're gonna look at a few of. I did get a few photographs from Kelly and from Helena, who Helena's not here with us this week, who did some interesting work on the problems, the challenges that we've been juggling. And so I'm going to do a little screen share, and we're going to just quickly look at some of those. I wish Helena were here because I could ask her some questions then. So I'll have to just sort of, I guess, reverse engineer. Now, today's reading, the title of the chapter that we're going to look at is on the causes of the influential configurations and of their degrees in number and order. He's going to be introducing, so we've been looking at a lot of metaphysics, and like we were talking about before I hit record, the thing about this book, on the one hand, I was saying to Nathan, I feel kind of bad that we didn't really work through books 1, 2, and 3 before jumping into the metaphysical book 4. But as Quan and Nathan both made the point, sometimes that's the best way, is to get a sense of the soul of the person, how their mind works, by getting into their metaphysical worldview. That takes, it didn't crop up overnight. This is the product of a lot of work, and this is called Plato's, we have dubbed these sessions Kepler's Platonic revolution in astrophysics. So it's good to, since he is a Platonist, to get a sense of what was his unadulterated Platonic philosophy. And he obviously thought this was the heart and soul of the book. And after working through the harmonics, working through the visual geometry, the visual harmonies, the audio harmonies, he's now looking at the harmonies of the soul. Like, what is harmony? What is it that has allowed us to carry out this investigation up until this point, which is what book 4 is all about. And book 4 is going to set the stage for book 5, which is sort of this synthesis of everything else into astronomy, and the astronomical data will then be evaluated with the resources that we've gained within our hearts and minds, regarding the knowledge of what are these geometric proportions, what is space, what is time, what is the shape and the structure. So obviously the idea of the investigator as part of the fabric of the universe that is being investigated, very important in Plato's world as much as it is for every great thinker, and Kepler is no exception to this. So before we look at a few quick ideas that'll set the tone for this book, or this chapter, just a quick reminder, this is something that Stephen was playing with, last week. Stephen's not here this week, but he was looking at the golden section. I liked his approach, and it's good to play around with just your compass. You use your mind and follow through. Well, what would be a necessary rational step when I start with a phenomenon like half a square, which was the starting point Stephen took here? How would I know what the diagonal would be if I build another right angle triangle with certain attributes that are common to the first one onto the second one with a new side of square root of 2? What would be the new diagonal, or what would be the new hypotenuse, I should say, and so on and so forth. And Stephen quickly noticed that he was building up something which featured squares of 2, squares of 3, squares of 4 at each of the hypotenuse, all the way to square of 5. And there's something about the square of 5, the square root of 5, and fivefoldness, fivefold symmetry that Stephen kind of understood as important in building the pentagon, but he didn't quite figure out exactly how this worked in the construction of that that five-folded shape, that polygon called the pentagon inside of a circle. He didn't make it that far, but I liked how he was playing with it. And there's other ways of playing with this too. And it's worthwhile thinking, okay, well, what would be the actually, I'll just pause on that. I don't want to give anything away. That was one of the constructions Stephen did of the pentagon. He had to do it by first building up the decagon, the 10-sided agon, at which point he could then pick out every second vertices. I liked that as well, and that was sort of the approach I took when I went through this years ago. But again, there's no single one pathway. There's many different approaches. There's not infinite possible approaches, but there are many. That's an important thing to get to the answer. Now, the challenge for the week has been generally prove the Pythagorean theorem, because if we're going to be able to figure out what would be the side of the pentagon, or the side of a triangle, an equilateral triangle inside of a circle, it would not be very useful. We wouldn't get that far if the radius was 1, right? That's the challenge. If we have a circle whose radius is 1, in which is inscribed a triangle, a square, a hexagon, a pentagon, what would the sides be if the radius was 1? You kind of have to confront the need to prove the Pythagorean theorem when you're doing this. So one of the images, when I was asking people to draw, well, what is the Pythagorean theorem beyond the mathematical symbolism? I think it was Kelly, right? Kelly, this is your image?
Looks like it, yeah.
Yeah, Kelly drew out this very nicely. You know, one small square is a squared, the other small square is b squared, the bigger square is c squared. And the challenge was now, how do you prove that the two areas of the two smaller squares, when added, to give you the bigger square, right? That was the challenge. So we didn't have too much interactivity, but we didn't have too many submissions this week. I had a lot of ideas from Kelly and from Helena, so I'll go through a couple of those. Quan had the excellent suggestion to cut out as many triangles to play with as possible. So Helena started by cutting out triangles of her square, adding them together. And I think this is a fun little construct where she just at least demonstrated that the small square is the equivalent to, if you break the first little square into 2 triangles, then you could see how 4 of those triangles fit into a square which is double the size. It's a nice little thing. It's not exactly the Pythagorean theorem proof, but it does a job nicely. And when asked her if she could clarify how this would be the Pythagorean theorem, because that's what she thought this was. Oh, I'm just gonna let somebody in the room. She came back to me the next day with the following image. So people see what Helena did? Why the 2 little squares would add to the big square? It looks nice, right? It's pretty good, pretty clean. However, then I asked her, well, but that's for the one case where the two smaller sides are equal. That works. But what if you made the sides different, right? A and B, if they were different sides, would that still work? That doesn't work anymore. So I asked her to try to draw it out, and that was the last thing she sent me, which was something playful. I asked her to follow Kwan's advice, and Kwan said cut out as many copies of the that first triangle as possible. So she did that, and that's a good thing. We should all do that. I recommend we all cut out like 7 or 8 copies of that original triangle and play with them. But the one thing she lacked that she didn't do, which would have helped her a lot, would have been to have also cut out the squares, the 3 squares that you can know, right? The 2 smaller squares and the bigger square. If she did that, on top of what she did by cutting out the equal, all these triangles, I think she would have found the solution pretty quickly. And then she did something else as a segue, and she sent me this picture, which I like. I like what she was doing. Where she was playing with her construction of the pentagon that she had done the week earlier, and found that by taking these little half squares, they fit very nicely around the pentagon, leaving a pentagon star in the middle. Of course, it doesn't really give you the answer of how this was generated or what the internal angles were, but it's a very nice point to explore. It's a very nice symmetry and a very nice point to explore. Kelly, just to restate, Kelly being the first to showcase what the Pythagorean theorem, what would a squared plus b squared equal c squared look like physically? Kelly was the first to hit that mark. Again, this is using a triangle that's a half square, not a triangle whose two small sides are different, but still good. And I gotta say, Kelly, your particular approach to proving why the two smaller squares equal the bigger square is the most original approach I've ever seen. Um, I really like what you did. I like how your mind works. There's a question I have. I redid this myself, and maybe you'd like to take people through what you were doing here. You want to do that?
Um, I'm not sure I can remember. You just, I was just playing around and
You were just playing around. Okay.
trying different shapes and angles, and that's what I come up
Well,
with.
you labeled them
Yeah,
very nicely. They
yeah.
made it very easy to follow by you
Well, that
cutting
would
up.
been
Hmm?
that would have been the last thing I did,
Okay.
just for so you can kind of understand it.
Well, I'm glad you did
But
that.
But may I interrupt?
Yes.
Because I agree with Matt. The way I look at your drawing, Kelly, the idea that you try to demonstrate that the c square geometric uh, geometrically is equal to a square to b square. That's what you were trying to do, if I understand.
yeah,
Okay, but by drawings, not by algebra.
that's yeah, exactly. I didn't
Okay,
even think of
that you
the
try to
algebra
cut,
yet.
that you try to play with right angle that you cut from cardboard or from paper.
Not this particular one. No,
Okay,
I just did
because
it out of my head, I guess.
okay, because well, I'm not in your head, but according to your drawing, you would mostly benefit from cutting four right angles. I'm quite sure you wouldn't arrive at the solution.
Hmm.
Yeah, the triangle. Um, when I was doing that, I cut them out. In fact, I cut several.
Okay,
This one, I you can't see it in the drawing, but there's like faint lines,
yeah,
like projection lines that I
okay. I would
there's a
like to give
method.
you a small hint. I would like to give you a small hint. Cut four right identical right triangles and play with those four. And according to what I see on your drawing, you won't arrive at the solution.
Hmm. Yeah. Well, basically, yeah. I do think that you proved, Kelly. I do think that you did successfully prove in the way that you broke things down here that the sum total of these two areas does configure into this area, into the big C squared area. You cut this first one into A and B as two triangles and you place them at two extremes, leaving you this big open gape, this space here that you had to figure out how does this space in the middle between A and B
Yeah.
somehow accommodate all of these different this whole space here, which
Yeah.
you found a way to break down. How did you choose this F and E? Like, how did you select those 2 points of this, making it a half square?
Uh,
Did you first build the square here in the middle,
uh,
that then gave you those areas, or how did you do that?
I started some. I could see starting from the bigger. I would probably use the bigger triangles first, like A and B,
Well, it's certainly what
and
you did.
then
100%. That's what you did. Yeah.
put them in some kind of place, and then what do I got left? And then I don't know, just kind of
Okay.
playing around. Yeah, just like doing a puzzle, a
Yeah.
regular puzzle. Does
Well,
this
it
fit?
Yeah.
definitely.
No.
Okay. Well,
But
it
but
definitely. Yeah.
a puzzle, Kelly, require that you have pieces of puzzle. I'm sorry to insist heavily.
I have to make my own pieces.
Exactly. No, exactly. You will see, make the pieces of puzzle in with the papers, and you will see that the puzzle you will arrive at the result quite quickly.
And
Yeah.
that's definitely true. Definitely playing around. And again, there's something about 92 different proofs geometrically for the Pythagorean theorem. So there's not just one. And it's always interesting to see how new minds approach this. Now this, keep in mind, would apply only to this one instance where you have two smaller sides of a triangle that are equal. But as
Yeah,
soon as
they're
you
equal.
create any triangle which doesn't have two equal sides, the proof you just did here will not work anymore. This only works for that one particular case.
Yeah.
Whereas quant is encouraging you to try something which will work all the time in every case of every
Uh,
right angle triangle.
exactly. Just adding a last detail in case I was not clear. When I was suggesting to make four identical right triangles in paper that you would cut, that right angle triangle have a side A not equal to B and of course not equal to C. Okay, so that right triangle
Mm-hmm.
has three different sides.
Mm-hmm.
So it would be a general solution, a universal solution, and not a particular solution, in case I was not clear.
Yeah, absolutely. And another example here, Kelly, where you had the idea of now getting at a more generalized solution concept.
Yeah.
And I like what you did. Kelly did
Oh,
something else that is very
this
interesting. Huh?
this is showing you before I made a mess of it. Not a
No, that's
mess,
good.
but the next picture you're probably going to show will be more stuff in it.
So the first thing I asked Kelly to do was to cut out some of the some copies of that original triangle, the way Helen did and the way Quan recommended. But Kelly went to the next level and cut out just a shit ton of triangles
It
up here and played around. But actually it kind of worked out in some ways. Your path of thinking.
it did, but yeah, it got too complicated.
No, well, it's interesting. I actually I think it's brilliant what you did, Kelly. I replicated it myself, and I don't know how the hell your mind did what it's about, what people are about to see, but you did something I've never seen before, and it works. Um, guys, this is a. I never thought I could see a new proof to the Pythagorean theorem that I'd never seen before, but here it is. Um, the only thing, Kelly. Now, you took that triangle, two different sides, right? The two different smaller sides.
Oh, you figured out the secret?
Well, I I reverse engineered it to the degree I could, and it worked.
Except,
Um, the only thing I couldn't figure out directly, I mean, I think I kind of have an idea. I'm guessing the first thing you did is you probably cut this middle square, right, in half. Hence, you named it 1, 1. Is that what you did?
um, how did I do this? This particular one, I knew that. Well, that square there, yeah, that would be the smaller one. I think I separated the bigger. Yeah, that's the bigger one.
Yeah.
No, I did the smaller one. I did that evenly.
Yeah, this
So
is
okay, so the bigger one,
mhm,
what was my attitude here? One big square,
mhm.
and then somehow the second square, like, or not square, the big triangle, the right angled triangle, and then the other triangle. I knew I couldn't use a whole one, so I thought, well, let's just like cut that in half, which I think that's what I did. And then the third, then the where the little ones are on there. Um,
The little ones here,
I
like
just
7, 8, 9, 10.
no, we're still on the big
Oh, this one.
square there.
Okay.
I I just kept dividing those,
Okay. Did
and
you?
I wasn't even sure I get it, but I don't know if you tried this, but one of those triangles, I think number six, it's so small on my screen I can't see it really.
You got 3, 4, 5, 6 here in the
Okay,
small
number
little
six
polygons.
is actually upside down, like on
Yeah, I see it here.
but it's reversed. We're like that.
Yeah.
The bottom paper is facing the top, if
Yeah, that's
that makes
fine.
sense.
Don't stress about that. It would still work the other way around. You just mirror imaged it. Um, I guess the first question I have is what made you decide after you did this first placement of the half of the medium square, number one, and you placed it inside the big square, that gave you then a choice because you have this two
Okay,
number two
first
polygon.
first
What
I
made
put in
Yep.
I put a number one square
I know.
or a triangle. I'm sorry.
Yep.
And then number two, I put a whole triangle to see how it might fit, and I overlapped it. And then where
Oh.
I overlapped it, that's where I cut it.
Hmm.
And somehow I think I tried to line it up with the smaller square, so it would kind of fit,
Hmm.
like in the middle there, the
Okay.
7, 8, 9, 10.
Okay.
So when I was cutting two, I cut it in such a way where it would line up with 7, 8, 9, and 10.
Interesting. Well, yeah, and the fact that the side of two here is definitely the same as the side of one. That makes sense. So it would make perfect sense that two here on the within the C square, the biggest square, would create a rectangle with the same side of one on the other side, giving you a rectangle that you then filled in with this half square of 7, 8, 9, 10, which is the total of the smallest square when cut up into triangles. And then you had this extra thin rectangle that you had to then figure out how does this remaining little part that you called 3, 4, 5, 6 fit into that new rectangle. And you did it pretty well. I wonder, did you cut? I mean, this is a direct halfway cut, like 3 and 6 are on
Yeah.
a perpendicular line. Is that a direct halfway cut with the
Uh,
horizontal line, or is it?
no, it's with the base of the each little triangle, I believe. It's not perfectly half.
I think it has
Um,
to be perfectly half for this to work.
well,
It actually
no.
does.
Wait, it depends what you mean by half.
Oh, I see what you mean. Maybe not, eh?
Because when it fit in the bottom,
Oh yeah, this is the diagonal.
it's really hard to explain.
No, no, I hear. Well, look, I don't think we should dwell on it too much because I don't want people to think that they have to do it this way. But all that to say,
No,
Kelly, big power to you, man. Big power to you.
thank
Good
you.
job. Really good job. Shockingly good. Now, that
I
being said, I highly encourage you to take Kwan's advice and go back to prove it another way, an even simpler way, by taking this triangle, make about 7 or 8 copies of this triangle and play with them around or inside of the space of around here and around here. If you play with those triangles, I
You're
guarantee you,
talking about the center triangle.
yeah, the first triangle, the
Yeah,
first
I think
triangle,
I did that actually, and I don't know, I didn't have success for some reason.
you will, you will guarantee it.
Is it allowed to give him a hint?
I don't
No,
know. I think he's gonna get it. It's so once you realize it and your mind realizes what's in front of you, it's just gonna seem so obvious that you didn't see it. It's one of those things. I guarantee you, you're
Yeah.
gonna have that moment.
Okay. But I would say something which is not really a hint. It is of a quarter of a hint.
Okay,
You have to start from your original drawing with
right.
the three square because the hint is in there.
Yeah, start
right.
with this one. Yeah. So start with these squares. Start with this drawing, and then with a more clean sheet right in front of your face. Then take your copies of this first triangle, ABC triangle, and play with them inside and outside of the space that you've created. Okay, just play with them. Have fun.
Thanks.
Okay. All right. So to recapitulate what we're about to see, obviously we're looking at Kepler's intervention into a very popular pseudoscience of the day that was very abused um, of astronomy, and it was abused very deeply. It was at the heart of a lot of the manipulations of the wars, the 30 Years' War. Many of the generals, including Wallenstein himself, who was a patron of Kepler, was a general within the 30 Years' War, and in the mess that led up to the clash of Protestants versus Catholics, tricked into killing each other for over a generation. This was it took a lot of effort, a lot of stupidity, a lot of superstition. Wallenstein was a deep believer in astrology, and that astrology should be a determining factor in how generals determine whether they go to war, how they carry out their battle, when they make peace. as was the case with many of the players in that great game. So Kepler was somebody trying to intervene to elevate the consciousness and understanding of what the hell we're actually dealing with when dealing with the positions of the planets around the sun and how they affect both the nature of geological processes, living processes, the souls of beings, living beings, which obviously have some influence or are being influenced by planetary phenomenon. But is that what shapes our destiny? Which is what most people tended to believe, that our fate is in our stars. And Kepler was not of that view, but he had to intervene on this mass psychosis in a very, very tactful manner. So he did it, and that's sort of the topic of especially what is going to be the next chapter and the chapter after that. And this is sort of setting the stage. So when dealing with the night sky, there's obviously, like we looked at last week, certain geometries that we all use and that have been used for thousands of years, namely the utilization of the celestial sphere, right? When we map out the positions of planets and stars, when we over time discovered that certain planets were wanderers, they were not operating in the same way that most of the stars were operating. So when we would go out at night and we would look at, for example, Mars, the only red star that catches the eye, right? Of the millions of possible stars, Mars is the only one with a reddish hue. So over time, people observing this recognize that when they go out at night at the same time every night, that the position of Mars did not necessarily behave the way all of the other stars did. All of the other stars would be predictable in their motion in a certain direction, whereas Mars would be moving in an opposite direction. But you wouldn't tell if you were just staring at the night sky, right, all night long, just tracking things in real time. You wouldn't notice that. You had to come out every night at the same time, let's say like 9:00 p.m., and take note of what the position is of Mars relative to the stars around it. And then you realize, oh, there's something different with that thing. And that was called a wanderer, right? And soon people realized, oh, other planets do that too. There are other wanderers, Mars and Venus, Venus and Jupiter and Saturn and Mercury. Mercury was harder to see because you could only see it at the horizon at the early morning and early night at times. But anyway, over time, there were techniques to measure these things that you would say, okay, well, this star, this planet is, we see it now in Leo, or we see it in Cancer, we see it in Gemini, based on what is behind it, what is the zodiacal sign behind it, and then we could compare it to, well, where is Jupiter relative to Mercury, or Jupiter relative to Mars? What's the geometry of the two? And here's some example of just some things we looked at last week, right? Sometimes the geometries are more interesting than other times. And we know from our work on harmonics that certain quantities will amplify and certain other quantities will de-amplify. So like if you have a string that is 2/3 next to a string that is divided by, you take 2/3 of one string, and you take a string of the exact same tension that makes the exact same frequency of sound as the first string, and you divide it by 3/4, and you pluck those together, you start getting a resonance. They amplify those wavelengths. Whereas certain other divisions, let's say the 5/7 division or 9/11 division, will de-amplify. They will cause the resonance to break of the first string of 2/3 or 3/4. So we have certain consonances, certain dissonances, and we also know that these consonances and dissonances are generated, as Kepler proved in book 3, from geometries, discoverable polygons that one can find within a circle. If you took the string and wrapped it into a circular shape, right, you could build those polygons within the circle. Some of those shapes are easier to discover with actions of the mind. Some of them take longer. There's more steps that the mind has to take from going from ignorance to knowledge. In the case of, for example, the octagon, you have to go through more mental steps than, let's say, the triangle or the hexagon, which takes fewer mental steps. And the pentagon takes even more mental steps. You have to discover more actions, right, in your mind before you can go from ignorance to knowledge of what you're dealing with. And so Kepler had a very unique way of saying, okay, the cause of the harmony of consonants being more or less harmonic with other consonants or other proportions is the degree to which the mind can make knowable those shapes that generate those fractions. And that actually is pretty satisfying. It even explains why many of the devil's intervals, the dissonances, are generated from shapes like the sevenagon or the 11agon are not discoverable. It's impossible to construct the sevenagon from within a circle. You can build it and then put a circle on top of it, but you can't start with a circle and generate within that circle a sevenagon exactly. Interesting phenomenon. Same thing for the 11agon. And the lack of knowability within the two-dimensional domain, the lack of knowability was a pretty satisfying reason why the actual sound is not harmonic. Pretty interesting. And this is just one such example. We're going to see many more of these in this particular chapter of how when Kepler looks at the angles of the planets, let's say one star would be Mars, one star would be Jupiter, from a God's eye view, and the middle point would be the position on the Earth. He's looking at the angles that are the shadows of elementary shapes, in this case, the triangle and the hexagon. Right? That's one example. And there's other types of angles. There's not infinite angles, but when you take your elementary shapes, there are certain quantities that are singular, that are of interest, that will be more useful for the explorer to discover and to hold on to. Some examples of the pentagon, when you aren't just the external parts of the pentagon, but also internally you can create a star, right? By connecting each of the vertices of the pentagon as it touches the circle. If you connect each second vertices, it will form a star, which has 72 degrees inside on one angle, 36 on another angle. For the smallest part, you have 108 degrees, which is also the same. See, there's a smaller pentagon inside, right? That would be what you would get on the outside also of the pentagon, the pentagon. And if you continue this process, in the case of the pentagon, if you then do the same thing to the hexagon and take every second vertices and connect them, you get one of these double triangles, right? And take the same thing now with a heptagon, a seven-sided agon, and take every second shape, every second vertices, and you connect them, you get a heptagon star. And the same thing for an octagon, right? It gives you two squares that overlap. Yep.
So if I can interject, I was just going to go back to that drawing before. You don't have to go back around the screen, but if you get the golden mean, if you.
Oh, sure.
Yeah, I just wanted to point that out.
Oh, yeah.
108 degrees, 36, 36.
Oh, yeah. Yep,
which is just really cool because didn't they talk about the Pentagon not being, or anyway, with Dur and all that? You touched on that.
Yeah.
It's
the
but
golden
this solves that.
Mm-hmm. Yeah, absolutely.
For that specific thing.
Yeah, you have to play with the golden mean. You have to discover the nature of the golden mean if you're going to properly construct the pentagon. That's right. And it's all over the place. We'll skip this for now. Kepler puts a lot of emphasis on a lot of these things. Now, I think the last thing I want to show before we read a few of these propositions and definitions is a video from a fellow, hold on, who has done some interesting work on earthquake forecasting that I think is insightful. So we're going to play it. I'm going to do share sound. This is a guy named Frank Hugerbeets, who I thought was interesting, and I didn't know about him until the the tragic earthquake struck in Turkey and Syria. And Frank Hugerbeets is, I believe, he's a Dutch astrophysicist who has come up with a very good, I think a healthy-minded approach. I think there might be some problems in how he approaches it, but I think the overarching idea is good, and he distinguished himself being that he was the only person to go public warning 3 days in advance that within 3 days there would be a likely case of a 7.5 or higher earthquake in the Turkey-Syria region. He's made a variety of these forecasts as well. They're not always, and we're not at the stage yet where we can perfectly forecast earthquakes. But there's ways of thinking about it that increase your power to do it more competently if you break with certain common assumptions within the standard model community of what geology is, what causes the earthquake, and what you have to look at. Hoogerbeets, I think, does a pretty good job, and this is something which we're going to see more of in Kepler's work. But this is a 3-minute video introducing Hoogerbeets' approach to earthquake forecasting, okay? And I put the sound on, so I think everyone should hear it.
Every celestial object with a hydrostatic equilibrium rotates and has an electromagnetic field, which is being generated by the axis rotation along the north and south pole, very much like a dynamo. Celestial objects also transmit electromagnetic waves. This was recorded for the first time by the Voyager spacecraft and again by the Cassini spacecraft. Due to this transmission of electromagnetic waves, there is always an electromagnetic connection between the Sun, planets and moons, whereby each connection has a very specific resonant frequency. When planets align, one planet may hit the resonant frequency of another planet, thereby causing an amplification of the electromagnetic resonance. This will also affect the resonance to other planets, very much like a power surge in an electrical circuit. When multiple alignments converge, the amplification of electromagnetic resonances will be even greater. Because electromagnetic waves affect the material world on an atomic level, an amplification will excite electrons, which causes a stronger vibration, and in the case of Earth's crust, this may cause earthquakes, typically over 6 magnitude. Indeed, analysis of large earthquakes in the past shows that they occurred around the time that planets were engaged in an alignment. While planets do not cause large earthquakes each time that they align, they do from time to time. It very much depends on the condition of Earth's crust and whether or not an area has sufficient stress to be triggered by incoming electromagnetic vibrations. This is a very natural process and part of the dynamics of our solar system.
Okay. So that was fun, right? All right, let's stop sharing. There's another, this is Frank Hoogerbeets' website. He created this solar system geometry survey, privately funded. And he's got some interesting updates on a nearly daily basis, just keeping track of the planetary, what he calls critical geometries, when they're more or less in resonance. And it doesn't mean, again, that he's always right, but he has a very potent approach, and he is more frequently right than all of the standard model accepted, geologists who tend to dominate the narrative. So people can watch his videos. This is the most recent one on his site from a few days ago, just to see his style.
This has everything to do with the geometry between Mars and Jupiter, as you can see here in the solar system, relative to Earth, which allowed the Moon to make critical geometry with both planets in a very short time. It started on the 17th when the geometry with the Moon, Mars and Jupiter came within 4 hours. It peaked on the 22nd, 23rd, and then on the 27th, roughly, it went over 4 hours again when the angle, the 90-degree angle between Mars and Jupiter widened.
So we hear that 90-degree angle between Mars and Jupiter. What shape would that be that a Keplerian would think about? Yeah, Nathan?
That's a square.
Triangle.
Okay, Kelly,
It's
yeah,
square.
square, exactly.
Okay.
Yeah, so that's the sort of and you got to think like, okay, if I was going to create a harmonic ratio utilizing the square, well, I would use the 3/4. That would be the ratio, the proportion that's generated between a half and a whole, which is the boundary conditions of an octave, the minimum and the maximum of resonance, right? So the 3/4 would fall in between. That would be what the square generates. And then I could think, well, would there be other critical geometries also either at that same time? And so it's a healthier approach than your typical weather forecast. Let's just, so yeah. And I think the other thing that's also useful is that either when you look at Hooger beats, or we had the lecture by Dr. Sergei Poulinets to the Rising Tide Foundation on Sunday. Everyone who's potent in this domain are all looking at the electromagnetic properties of the solar system as a whole, as far as they relate to the behavior of weather, the behavior of earthquakes, volcanism. And I think if we start looking at the evolution of species and maybe even matters of the mind on a subtle level, even, we might find certain interesting correlations at some point when society or science begins to mature in these fundamental relationships. So that's all I wanted to show before we start reading a few elements of Kepler's Harmonies for tonight. Do people have any thoughts or questions before we start the reading?
Oh, I've got some comments on that. Because I was kind of researching it a little bit about. I was trying to understand how does the dialectic magnetism work. So I've got some thoughts to share on it.
Sure.
And it relates to geometry too, but I'll just do it later in my notes that I'll send.
Sure. Yeah.
Because there's other resources on YouTube that I saw that informed me. I was researching.
Cool. All right. So yeah, I guess we could break out some of that in the dialogue process when we're done. And we're just gonna read maybe 3 or 4 pages today. We'll see. But I was thinking, I wrote down here the ones that I'd like to really just cover today quickly would be definitions 1 to 2, axioms 1 to 2, and propositions ideally 1 to 6, to give a sort of flavor of Kepler's thinking on this matter, and then people could read the rest on their own before, and then next week we'll read chapter 6. All right. So who wants to be a reader today? Anyone?
Well, I can read since
Cool. All right.
so do we begin?
Yeah, sure. So it's called On the Causes of the Influential Configurations and of Their Degrees in Order and Number.
Okay, so definition 1. The word configuration is used for the angle between two rays, each descending from its planet. The angles at which the rays meet here at the Earth, which is deemed to be a point, which comes to the same thing, or which comes to the same thing. It is used for an arc of the great circle drawn on the zodiac. The arc, which is the measure of the said angle, or the arc which the two planets seems to mark out by the interposition of their bodies, and so to speak, cut off for us dwellers on earth. It must first be noted about the name that Ptolemy, in his Tetrabiblos, in his Almagest, and in his Harmony calls appearances, what the Arabs translated as aspects, as if a countenance were the same as a visage or face. Our Teutonic idiom does the same, as as it generally names a face das Angesicht aspect, and the countenances of characters who are impersonated placed in front of the face, Gesichter, which the Italians call maschera for mask. However, the word regard is also found in Greek, which not only do we, following the Arabs, translate as aspect, but also good authors generally call lux in Latin and the sign onlookers. But in this sense, the word is less appropriate for the planets than for the signs or 12 parts of the zodiac. For as they have length, with their inner side, they can be turned towards each other to a greater or less extent. For contiguous signs cannot look at each other, seeing that their faces are not turned towards each other, but are nearly turned in the same direction as each other. Second, note that at the same time as two planets make an angle at the Earth, they also make another angles at different places in the world, but never the same size as on the arc of a circle passing through the bodies of themselves and the Earth, or rotated about a line which joins their bodies as if about an axis. Outside these places, their radiations meet at angles which are far different, whether they are also harmonic or incongruent, as they generally are throughout the rest of the world. Note chiefly that no angle is set up at either one of the planetary bodies, for two rays are required for an angle. But every ray is outside a body and none is actually in the body. That must be noted because the formation of an angle at the Earth is followed by an effect on the Earth also. And from it, at the time of the aspects, the material of rains and of other occurrences in the sky is exhaled. Hence, we can argue of the seat of the cause which sets in motions occurrences in the sky, that it is not in either one planet or the other, nor in any empty place in the world, but in the Earth itself. Third, it was not superfluous to mention that the Earth functions as a point. For the result of that is that although there are innumerable animate beings on the Earth and an infinity of rays from any planet to them and other points on the Earth, yet the angle between the rays coming from a pair of planets at the same time is sensibly the same at all points of the Earth, whether at the center, on the surface, or in the caverns of the mountains. Although all those aspects are infinite in numbers, they are taken as a single aspect, seeing that they are all sensibly equal to each other.
So far, so good.
Yes. Do you want to make some comments on that?
No, just to say, I mean, it's like, because if you're thinking about it from the standpoint of like a literalism, one would say it's got to be in the center of the Earth that we would want to calculate the aspects, right, of the angles from whether, you know, two different planets as they connect, or from my little position where I'm calculating them in my observatory on this particular surface of the Earth, which wouldn't be the same as somebody living in Hawaii, right, or somewhere else. But he's saying, look, from the sensible point of view, even though it's not literally the exact same, it's so far away from us that it sensibly would be of the same effect. So he's allowing a certain degree of generalization there to a certain
Yeah,
limited bandwidth.
absolutely. Common sense in
Yeah,
exercise.
common sense.
Okay, do we keep on with definition 2?
I think so.
Okay. Definition 2. A configuration is said to be influential when the rays of a pair of planets make an angle such that it is apt to stimulate sublunary nature and the inferior faculties of animate beings to be more active, each about its own activities at the time of the configuration.
And every time you're going to see this, we're going to see this terminology a lot, sublunary nature. All what that really means, it's a very comprehensive idea of all geological, living and human behavior that is, everything under the moon, pretty much. Everything under the moon, and how changes happen in those domains: living, non-living, and thinking.
Influence is attributed to a configuration which formally is an entity of the reason, but not immediate influence on the thing itself, as if rains and the like fell from the actual heaven, that is to say, from the planets which are in the configuration, which is the foolish persuasion of the common herd, but mediate and objective. For just as object move the senses, sound the hearing and not the eyes, and color the vision and not the hearing, similarly, in this case also, a certain quality of this relation, which is called a configuration, moves not the bodily senses, but a spiritual faculty capable of reason by instinct without contemplation. Therefore, the configuration brings that about not by its own force, but by the force of the soul, which is said to be passive, although in actual fact it rather acts itself on itself. After that, the sublunary soul or nature, thus moved or stimulated by the aspect and reminded of itself, stirs itself up to draw out from the bowels of the earth the material for every kind of weather. If there were not in the earth the soul, which we call sublunary nature, the planets of themselves could have no effect on the earth either on their own account or by means of a convenient aspect. For it is absurd and like a joke or a flight of poetic fancy to suppose that from the coming together harmonically of a pair of rays, as is from the coupling of a man and a woman, a vapor is conceived as the material for wind or rain, as if indeed as the seed is of the substance of the parents, so the moisture and other things which are exhaled from the earth are of the substance either of harmony, which is a relation, or of an angle, which is a qualitative quantity, or even of light itself, which is a quality and by no means a substance. In fact, in the same way as we say that nothing can come from nothing, so also, naturally, nothing material can be drawn from something immaterial. See further chapter 7.
Yeah.
Any comment before I go to axiom 1? Okay,
Chapter
no
7
comment.
is going to be the intense chapter that brings a lot of this together. One of the ideas too, this idea of Kepler of the sublunary soul, the soul of nature, it's very similar to Leibniz's monadology, Leibniz's concept of the monad. And not to say that all, because he's partially getting at the idea that in order to have a harmonic response to a harmony that's brought in on the physical domain, there must be, as we discussed in the previous 2 or 3 chapters, something that allows that to happen. There must be something of the immaterial domain that exists in order to allow for the material resonances to exist. And if the planet as a whole is exhibiting, or planets as a whole exhibit evidence of similar recognition of resonances, then there must be something. You wouldn't say it's the same thing as a human soul, but there must be something of a soul-like quality embedded within nature. That again wouldn't be the same thing as a human or even as an animal, but it would still have to be acknowledged as something as such, which is what again Leibniz develops in his monadology.
Absolutely.
A
So,
question.
Mhm.
Is he referring to like the Earth or the planets with souls?
yes.
Okay.
Yeah, in case it's not clear, Kepler was proposing that the Earth has a soul.
All right.
It's so much harder to understand this when I'm not reading it by myself and listening up. But something that helped me gain some clarity was just understanding principle and attribute. Notion of principle and attribute. So the conjugate is like the principle.
Yeah.
I don't
Well,
know.
When you say conjugate, what do you mean?
The
configuration.
configuration. Sorry.
Yeah. No. He is speaking here of an angle of defined by the rays coming from 2 planets and
Right.
landing on the Earth.
Right.
An attribute, would that
Yes,
be like some kind of characteristic?
Yeah. I see, Kelly, that you are now mastering the philosophical psychobabble. Congratulations. Exactly.
Thanks.
That's an
Thanks, but it
attribute.
actually worked when I read it. Okay.
It's been latent for many years. It's just starting to come back.
No, exactly. That's an attribute because you can measure it.
That's good. Good point.
Yeah. And if you cannot measure it, but it has to come from the soul, that would be a principle.
Mm-hmm.
Right.
Well said. That's good. I like that.
So Matt, we read axiom 1, 2, and proposition 1 to 6, is I remember?
Yeah, I think that's a good aim, a goal for tonight.
Okay, cool. No other comments before I start the reading? Matt or?
Yeah, I guess one thing is just to hold in mind, because I know some people, including myself, when I first read this, my alarm bells went off because you have the a lot of very, very troubled people in society who tend to get into a bit of a Gaia worshipping as a cultish way of being. You know, James Lovelock and Lovejoy and many others who don't necessarily play a positive role in human affairs, posit Earth souls too, but there's a very different way that they're thinking about such things that Kepler and Leibniz and Plato are not thinking. So it's good to always hold in mind what's the difference in how they're thinking about these matters, these cosmological concepts that are not compatible. How are they the same and how are they different? Because if you make a subtle shift of gears, you could go down a really terrible path. Yeah. So just throwing that out there.
Okay. So axiom 1. The arc of the zodiac circle, which is cut off by the side of a figure or of a star, which is congruent and knowable, measure the angle of an influential configuration. Axiom 2. The angle of a figure or star which is knowable and congruent is the gauge of the angle of an influential configuration. The home business rests on the two axioms. And the reason why I have made them two is that there are two probable means by which souls and sublunary nature can come to knowledge of the configurations which exist at a given time.
I have another question.
Okay, go ahead.
What's congruent?
Meaning the same size.
Okay. Thanks.
Not necessarily the same, but it's like 12
proportional.
Proportional, yeah, like 12 and 4 you could say are congruent because there's 3 times 4. 4 could fit into 12 3 times, whereas 12 and 5 not congruent because 5 doesn't fit into a 12, right?
Yeah. So
like,
the home
kind of like the same family, maybe, perhaps.
Sure.
Well, proportional, because let's not forget that we are discussing of harmony and of harmonics. So it's about harmonic proportions.
Right.
Okay.
So the whole business rests on the two axioms. And the reason why I have made them two is that there are two probable means by which souls and sublunary natures can come to knowledge of the configurations which exist at a given time.
Is it just me, or do other people are other people following where Quan is?
Yes, I read the second time the same 4 lines.
Oh, sorry.
That's okay. That was an excellent sign that you were truly following, Matt. Congratulations.
Thank you. Thank you, Sensei.
But this time I will not read the second time the same 4 lines. I will go to the next paragraph.
Okay.
For they either perceive the figure of which a side cuts off an arc of the zodiac circle as the measure of the configurations, or of the angle of the rays, or the figure of which the actual angle of the configuration is an element. What the distinction is between the figures and what, on the other hand, the affinity is evident to the eye from these diagrams, which follow each other in order from this point. For the pairs of diagrams are matched. First, a diameter with itself, whether it bisects its circle, being drawn through its center, or touches it when the two rays make as their angle two right angles, or rather no angle, being arranged in a single straight line. The same must be supposed of the conjunction of planets, either superior or inferior, which is improperly called a configuration. Okay, so superior is when it's on the same side of the sun, and inferior is when it's on the opposite side of the sun. Mm-hmm. For if two planets were at the same point on the zodiac, then there is no angle at the center, on the circumference an infinite number, and the sides of the figures are points. That is to say, the circle is like a figure with an infinite number of angles. This configuration had no need of visual representation. Second, the square is also matched with itself because the angle which two of its sides form at the circumference is equal to the angle at the center subtended by one side. After that, the triangle is matched with the hexagon, the pentagon with the 10 angle star, the octagon with the 8 angle star, the decagon with the 5 angle star, and the dodecagon with the 12 angle star, in such a way that if all the angles of one member of a team are drawn at the circumference, its side subtends one angle located at the center of the other member.
So we have their Yeah, some people can
Go
follow
ahead.
those visual images of 1 and 2 when you have two 180-degree diameter representing the positions of two different planets on either side of us, right? Two extremes of the zodiac, or you can imagine them also in alignment with each other, making no polygonal shape. Whereas this one that he just expressed would have a 90-degree example, like what Huger was looking at as that one example on May 30th around the Earth.
Okay. Now the centers of all the circles suggest the Earth as if it were placed in the middle, and the circles themselves represent either the zodiac as pictured from the Earth, or whatever other circle subordinate to the zodiac is pictured in order to measure the angles. Such circles are potentially the actual souls which are moved by the aspects. That is, circles abstracted as if were from actual quantity and constrained within the restrictions of a point which has qualities and is capable of having directions. However, I have placed two radiant stars outside this circle, one higher than the other, to convey by a visual representation that it makes no difference to the configuration at the Earth whether the planet is high or low in the heaven, and one can be many times higher than another, while the configuration at the Earth remains the same.
Yeah.
I think here it's another way, convoluted way to say that it's so far away and it doesn't matter.
Yeah, well, yeah, but also that sometimes if because you could look at the planets from two directions from the standpoint of the Earth, which sometimes involves the planets being more or higher or lower below or above the plane of the ecliptic, which is the plane
Yeah.
that is shared with the Earth. And sometimes, if you see one planet there, like, you're looking at the night sky, you see one planet in a position, and the other planet is like let's say 30 degrees that way, but higher up, it might look a little bit, you might not really appreciate
Right.
what he's saying, but it's like he's like, you can get rid of that if you take the God's eye view and look down upon the process like we're doing with these little diagrams. You wouldn't see that differentiation of higher or lower. You would just see the angle, and that angle is more important.
Exactly. Okay. Furthermore, it came about not by accident, but on purpose that in the first axiom, the word congruent comes first. In the second, the word knowable. For both figures share the responsibility for some aspects being influential, the one which is drawn at the circumference as well as the one of which one angle is formed by the rays at the center. Both of them on account of knowability as well as on account of congruence, yet they are not equally responsible. In other words, the aspect is defined not by the angle between the actual rays coming from the planets, but by the angle between their lines of longitude. All that demands a somewhat more extensive explanation. And there is a single reason why it is so prickly, so that the number of aspects can be reduced by philosophical arguments, or at least can be differentiated into definite degrees. For if I had been willing to include 4 additional aspects along with the usual 8, this discussion could have done without several, so to speak, propositions which follow, seeing that they are taken up only with comparison.
So
Any
now,
comments before I keep on?
well, I think we're going to see now some examples. So he's going to now go into concrete examples of certain relationships and ratios that are more or less either congruent or, more importantly, knowable. As I mentioned earlier, right, the knowability function that a triangle is more knowable than a pentagon is Kepler's insight into the degrees of the mind, right? But also the reason for why certain harmonies are more or less or not harmonic with each other is the degree to which the knowability is more or less so of the constructible figures that generate the harmonies, as we will now see within certain configurations of the planets.
Do you mean it's like easier to see things in 2s and 3s instead of 5s?
Don't think about it as long as you're not thinking about as number, but as long as you always have in your mind that when you're looking at number, you're looking at the qualitative shape that generates those numbers.
I think that's what I mean, yeah.
That's what you mean, then yes.
Okay. So proposition 1, the affinity between the rays and a circle and its arcs is greater than was that between the consonances. The basis of what was previously stated in Book 3 were already justifiably taken over into Book 4 as an axiom. However, it is proved as follows. 1. Consonances are between sounds. Sound consists in motions. Their heights or depths in pitch by which the consonances are expressed arise from the speed and slowness of the motions by what has been demonstrated in Book 3. But the quick and slow sounds are elicited from the striking of strings, which are stretched not only if the stretching is in a circle, but also and much more if it is in a straight line. Therefore, the consonances do not relate immediately to the circle and its arcs on account of their circular shape, but on account of the length of their parts, that is, their mutual proportion. And they have what they have from the circle, even when the circle has been destroyed and stretched out into a straight line. Aspects, on the contrary, are by definitions angles, which the circles measure along with its arcs only if it remains what it is said to be, that is, insofar as it both has its circular shape and retains it completely. 2. The consonances were not all propagated with an equally close relationship to the circle and its part. For some of them related their origin to parts of the circle insofar as they had some property not as parts of the circle, but as straight lines, that is the same division as the whole circle, as was shown in Book 3. It is the opposite in the case of the aspects, for the measure of what corresponds with the circle cannot in any way be related to straightness. It's true that this guy is absolutely brilliant. He was already speaking of slow motion and fast motion even before the modern measurement of sound frequencies.
I gotta say, when I was practicing my geometry there, I'm realizing that, yeah, when we're talking about the circle and the radius and all that, I realized there's no way I can get a direct relationship between my lines that I draw and in relation to the circle, just like Kepler is saying. It's like they're two different things.
Yeah. Yes. And here he was speaking of two domains of phenomenal reality, okay? The domain of the sounds which can be measured in terms of slowness or fastness, but which does not require to be, I don't like the word, but to be imprisoned in the framework of the circle. But when you are speaking about aspects or configuration of rays, we are more attached to the framework of the circle because we need the angles, and it's not the case with sounds. Okay, when he was speaking of consonances, he was speaking about pleasing sound to our ears.
Yeah, that's right.
Yeah, that's going to take a couple days to digest.
Well, that's the easy way to look at it. The more complicated thing is just how the forms, the sublunary nature can be more through instinct can be more in tune with the form. I mean,
Yeah.
at times then, yeah.
Yeah, to be congruent, okay, because let's not forget that the two major intellectual concepts that he was proposing, either for the sound domain or for the aspect or configuration domain, is knowability, and the other one being congruence.
Yeah.
Yeah.
And let's not forget that the books is about harmonic proportions. Okay, that's the big concept.
Mm-hmm. Mm-hmm.
Okay.
What does he mean exactly by knowability? Like, I know what the word know means. Does he mean something slightly different?
Yeah. Are you capable to measure it?
So
are you capable? That's the first level, but there's another epistemological level. Okay, when Matt was speaking, what would you discover by the triangle within the circle or by the pentagon within the circle? With the pentagon inscribed within the circle, you would need more mental step to discover the different laws. Okay, so the knowability has more depth in the case of a pentagon than in the case of a triangle. That's the epistemological journey, playing with the interaction. Let's not forget that at the beginning of book 4, he was speaking of the play of the soul having two objects, the circles and the lines, and how you would play with the lines inscribed within the circle. And that is the knowability. What would you discover in your epistemological journey, playing with those two objects of the mind? And we are not speaking of the circle on the paper, but the circle as an object, pure object of the mind, of the soul, and the lines as a pure object of the soul.
So knowability is discovering some kind of truth, I guess.
It's the epistemological journey, okay? It's Kepler's words for my favorite concept of epistemological journey.
Okay.
So I have a quick question. Did Kepler see when he looked out in nature that there weren't any real straight lines?
Yes.
Yes. And let's not forget that he was living at a period that the circle was a sacrosanct and an absolute representation of harmony.
So what did the straight line represent to him in his time?
Well, precisely what he said at the beginning of this book, okay? Those straight lines are the second, if you remember at the beginning of book 4, he was speaking of the fact that you have two pure objects of the mind, the circle and the lines. And those lines are a partner of the circle to create objects of the mind that would correspond to harmonic proportions that you would discover in your epistemological journey, or what he called knowability. It's a tool for play for your epistemological journey.
It's kind of like the straight lines are in our mind.
Yes, it's always a mental object, okay? It's never a physical object, because once again, he's a Platonist. Everything that you can create in phenomenal reality is only a secondary product because you explore your mind first.
Yeah, said otherwise, the idea that nothing from the Platonic worldview, one would say nothing could be created in the material world so perfectly that something more perfect could not be created. So there's right as much as you could draw that perfect circle, you cannot say that a circle can be drawn so perfect that something more a circle yet more perfect could not be drawn. That would be an impossibility. However, the circle does exist in that higher state of reality that gives rise and infuses meaning into the existence of the circles that we physically identify with our physical eyes and bodies that live in the material world of finiteness and change. We can identify these identities because of that higher existence of that divine reality that doesn't change. But that would be sort of the simplistic way of sort of boiling down a Keplerian Platonic philosophy or philosophical, worldview.
Yeah.
I don't know if did that make sense, Caprice?
Yeah. Yeah.
It made me think the more I know, the more I don't know.
Yeah, no, it makes sense. It's just like it's easy for me to conceive of a straight line and measure a straight line, but then when I look at nature, there aren't any. And
yeah.
Right.
Yeah. Yeah, even like when you have like a laser beam that seems super, super straight, even there you start discovering, there's like a little bit of a curvature in the fabric of space-time itself, which means even that can't be perfectly straight. So yeah.
Yeah. And I cannot resist to remind everyone that the Greek word, the cosmos, doesn't mean the universe, the physical universe, okay? The Greek word cosmos means the God's plan, if you want, or the cosmic mind's plan. You take the expression you like, depending of your personal beliefs. That's precisely the idea too about the epistemological journey, because the inner cosmos is also a step in your epistemological journey or in your degree of knowability. Okay, so cosmos meaning God's plan is also if the human mind is made in God's image, it means that there can be a congruence or a proportions or harmonic proportions in the epistemological journey in discovering that God's mind or God's plan.
I like that.
Mm-hmm.
Yeah, thanks, Quan.
Yeah.
Oh, I see in your answer, Kelly, that definitely you are becoming a philosopher.
Yeah, but I think you're taking extra effort to try and make us understand as well.
Well, that is one of my pleasure. So do we have other comments before I read proposition 2? No? Okay, so let's read proposition 2. Okay, proposition 2, the affinity between the rays and the regular figures is greater than was that of the consonances. It is proved first by the figure at the circumference. For where the circle is complete, in that case, the regular figure is also complete. But the circle is more complete by measuring the angles of rays. Then the figure also can be considered more as complete in relations to the rays. It is the opposite in the case of consonances, as the circle and its part could be stretched out straight while preserving the consonances. So also all the sides of a figure could be stretched out into one and the same straight line and could make a consonance with one straight side of the figure. On that basis, indeed, just as the circle loses its configuration, so also does the rectilinear figure, meaning the straight line, so that it is no longer a figure. It is proved second by the figure at the center. Angles are the elements of figures. In this case, two rays make the angle at the center, and if that is repeated a certain number of times, it completes the figure as is apparent from these diagrams. However, that was not the case with the origin of the consonances, the pleasant sounds, for there was no relationship with the angle at the center in that case. Therefore, the figures are more closely akin to the aspects than to the consonances. I think here it's obvious, it's in the sounds are not determined by the angles of the vibrations, but rather by the slowness or the fastness of the vibrations. Okay, so it doesn't have to do anything with the angles.
But also, it's yeah, when you unwrap the circle into a straight line, if the circle has been if within the circle we have found like an octagon or any of these shapes that we've just been seeing, then it would create a proportion of like 7 to 8, or 1/7 to 1/8 to 7/8. That could then be related, but as a line that is then created as a proportion, which is not a direct circle, but derived from the circle. Whereas the aspects more directly derived straight from the circle with no extra steps.
Absolutely.
And yeah, so he said that I don't want to interrupt. I just talked to try to gain clarity for myself. Keep going.
No, go ahead. It's a philosophical discussion.
The studying the line without because it doesn't take into consideration the arc, and so it doesn't. So the consonants, if you can't explain something, you don't understand it. I can't explain it. So you just mentioned that you don't have the consonants in the for harmonics in sound, the line. Okay, so it doesn't. Does it? How are the consonants impacting one's the emanations that can bring awareness of the harmony? Well, knowing where the consonants are.
Well, the consonants
it's much easier with the arc, right?
Yeah. Well, it's important for the consonances to have harmonic proportions, because let's repeat that consonants only means a pleasant sound. Okay, contrary to dissonance, which is a jarring sound. So when we have consonances, it's only our own way to say a pleasing sound to the ears of a human person. So when you have a pleasing sound to the ear of a human person, we are speaking of harmonic proportion. For example, 2 to 1, which is an octave, or a perfect fifth, or a perfect third. Those things you have harmonic proportions. So the common concepts of consonances and configurations is precisely the big concept of Kepler's book, meaning harmonic proportions. Okay, the only thing that he says here is that in the case of the aspect, meaning the configurations of the stars, you need to stay within the framework of the circle to have a meaningful phenomenal representation. Okay, but the concept that is putting together the pleasing sounds and the configurations of the planet is the concept of harmony, of harmonic proportions, or congruence. Okay, and let's not forget the big concept is harmonic proportion, and under harmonic proportion you have two sub-concepts: knowability and congruence. Okay, but I prefer to put knowability at the top, because after all it's epistemology. Okay, so I cannot put epistemology at the second place. So you have epistemology, and you have harmonic proportion, and you have a lesser meaning of
and that's why knowability has to be higher, because the world we live in.
Exactly.
So
he speak, well, that's I think that the translator translated correctly, because he used older version of English to reflect the older version of German, I suppose. And
okay.
Yeah, and I just that was really well said, Quan. And I just to add to keep the idea, I think, simple, what he's doing is he's looking for the similarities and differences between two spaces, the visual and the
Mhm.
audible space, which
Okay.
they both recognize ratios, harmonies. They both, as we now know more clearly, um, receive frequencies, right? Just one is light frequencies that's much smaller than the sound frequencies, but
Yeah.
everything travels in frequencies. So there's neither one by itself would give you the type of solution concept that Kepler generated when developing his three laws, but it was by finding the ironies between the audio and visual spaces that he was able to then mentally make the breakthroughs that he needed, that he was able to do. And he's trying to help us. He's sort of tickling us and playing with us
I
to
see.
sort of appreciate how these two spaces interact and how they're different.
Earlier, he said the
I see. Okay.
consonances are between the sounds, and the sounds consist of motions.
Mm-hmm.
Absolutely, absolutely. And I said that that guy was truly brilliant, okay, because he understood the concept of frequencies. But I suppose it's a
Yeah.
little bit. I suppose it's a little bit intuitive too, because when you see a string vibrating and that vibration is making the sounds, okay, so the idea of fastness and slowness of the vibration would come spontaneously to the mind.
Yes, absolutely. Yeah.
You know what I absolutely think about is like I look at the work that you and your wife have done, Matt, about Tavistock and the
Mm.
Beatles. And for some reason, there are some Beatles songs that just like oh gosh, what is that one with the violin? I was just looking at it. It's Eleanor
Fool
Rigby.
on the Hill.
Oh yeah.
Has anybody like Eleanor Rigby is like oops, sorry, like zzz, like it's so dissonant.
Eleanor Rigby.
And then they go like
like
but it's just the strings are
yeah.
so dissonant that I can't even listen to it. It just
Yeah.
it's
I know
so
what part you're talking about. That, yeah, that part. Yeah.
yeah, the part
Mhm.
where they do just the
Yeah.
strings that are completely
Yeah.
dissonant. And I go,
Well, I mean, yeah,
Yeah.
that's a multifaceted attack on the soul in terms of the lyrics, like what
Yeah.
message is being communicated with all the lonely people, and what cathartically is going to be generated in the audience admiring that, as well as some of the very pleasant modes that are used that are then tied to certain very dissonant
Mm-hmm.
sounds as well. That I think a lot of this stuff, yeah, was done with a malevolent design. Though I don't necessarily think the Beatles, maybe Paul McCartney, but generally I don't think the Beatles knew what they were, the damage they were necessarily doing. But when you listen to Paul McCartney's "Bang Bang Maxwell Silver Hammer," when the kid sociopathically kills his parents and teacher and date, um, you're like, nah, Paul McCartney was messed up. He
yeah,
probably knew what he was doing.
you got to do something to get sir in front of your
Yeah,
name.
you know.
But yeah, that's the ultimate like dissonance that I hear is
Yeah.
yeah. I think the problem is like so many people don't listen to music that is consonant. What's the right term?
Yeah, consonant. Absolutely.
Consonants.
That's
You
it.
Like
want to
Yeah.
we
you want to
don't
hear
get that
this?
music now, right?
But
You
but
want to
they
hear
talked about that too when a lot of the music was just focusing on the harmony, and the space in between that was kind of the commentaries that they would use when he was talking about music.
Yeah. But once again, I cannot resist to say that it's not important that the music that you are listening to is consonant or dissonant. It's what is important is that your soul is capable of consonance.
Mhm.
And if your soul is capable of consonance, you can read, you can listen to any stuff, and it would be your soul that would determine your thinking and your action.
You mean someday I'm going to actually enjoy jazz?
Yes, well, you might not be enjoy jazz because it's a very subjective experience, but you would be capable to see what is interesting in jazz and not be unconsciously be driven by the darker aspect of certain music and not okay because a person that is perfectly consonant within his soul would be capable to listen to metal music. It would not be very enjoyable, but his soul, his mind, and his behavior would not be unconsciously affected by listening to metal.
Oh, I see what you're saying. Yeah. Well, that's the thing, right? It's like people often treat advertising like as if it has this magical power of acting on our subconscious, which it kind of does to the degree that the population is not self-aware and is, you know, if we're stuck in that state where our subconscious unexamined forces are running amok with our emotions and our desires and identities, yeah, we'll probably be more like susceptible to hypnotic suggestions, you know, through all sorts of commercial advertising and subtle messaging in our media and other things. But if you become more self-aware, it's kind of like a spiritual inoculation where it just doesn't phase you in that same way that it used to before you sort of woke up.
Absolutely, I say amen to that, because if you don't have that kind of right attitude, you wouldn't always say it's because of the order who influenced me. Okay, if the orders tell you to jump from the bridge, are you going to jump from the bridge? I know that I gave a caricatural example, but it's tantamount to that. If it's your responsibility to be on the epistemological journey. But here I stop my preaching.
So I guess you could also say there is a higher consonances and a higher consciousness.
Absolutely. Yes, absolutely. And that's what we are discussing here at Rising Tide Foundation when we read those texts from Kepler or from Plato, etc. Okay, because once again, I repeat my caricature. Okay, it's exactly the same than the guy who would say, I jump from the bridge because the guy told me to jump from the bridge. Okay, you have a soul that can be activated, that you're not forced to listen to him when he told you to jump from the bridge.
So higher consciousness, higher consonance.
Yeah. higher harmonic proportions. Okay, do I keep on with proposition 3?
Yep.
Okay, proposition 3, the congruence of figures is capable of more in establishing influential configuration than in the case of consonances. Many arguments for this point are forthcoming. 1. Congruence is a property of a figure insofar as it is a whole figure and has an appearance. But a figure, insofar as the whole of it has this appearance, first, in itself, on its own account, has more affinity with configurations than with consonances by proposition. 2. Second, it divides the circle as a whole harmonically, but the circle also has more affinity with configurations than with consonances by proposition. Hence, on both showings, on that of the figure independently and that of the figure and the circle in common, the force of the congruence of figures is also greater in configurations than in consonances. From the number of figures, for we have taken it on account of the axiom previously stated, that figures are influential on account of their properties. Then, where the number of the things influence correspond more, there is a greater affinity between cause and effect, at least probably. But as the congruent figures are few, so also the aspects are few, as experience testifies. For if they were not few, there would be a great confusion of them and a great multitude, so that individual aspects could not be observed separately on their own days. But that can be observed. Therefore, they are not infinite in number. On the contrary, the consonances can be infinite by augmentation of the intervals by diapasons, just as the knowable figures are infinite.
Here by diapasons, he just means by always adding octaves, you can always add more consonant frequencies on a string. So you could always just make the string bigger, make more octaves infinitely, right? Same thing for, you could always add more knowable figures in the sense, you know, you can make a 24-agon, a 64-agon, a 8,000-agon, you know, you keep doing it. Kind of like counting to infinity plus one, right? You'll always be able to do that. But there's something else which is more, which is bounded as a many, a quantifiable many as well, between the one and the infinite.
Okay. And please focus for the next paragraph, because there would be a big concept. From the essence of the terms in which the proportions in either direction have their existence, motions of which sounds are a disposition are considered as becoming insofar as they take time. Radiation more as instantaneous being. For just as a body exists at this moment, so also a radiation exists at this moment. Whereas of motion, what has passed no longer is, what follows is not yet, in a moment it is nothing. Congruence, however, seems to be among things which are rather than among those which become. For the size of a wall of a house are congruent so that the house may exist, not so that now and perpetually it may be built. From the affinity of congruence as cause with configurations. For the latter are angles, but the congruence also exists in figures on account of their angles. So here, when they are speaking of congruence, it was really the harmonic proportions, an object from the soul. That's why Kepler was speaking more of being. So far, consonances and configurations have been opposite to each other. In what follows, there will be another opposition among configurations alone between congruence and knowability.
All right, let's make this our last proposition that we read for tonight.
Okay.
Oh, maybe we'll go on to 6. It's not too long. All right, let's see what we can do.
Oh, only 6?
Yeah, I think let's aim for 6. Let's do 6. It's a juicy one. Yeah.
Okay, cool. Okay, proposition 6.
No. Oh, no. I'm sorry. I meant let's go up to 6. Let's just push on. Probably. Yeah. Let's just do it.
Just 6 or 4, 5, 6?
No, 4, 5, 6. I'm sorry.
4, 5, 6. Okay.
That was dissonant.
Yeah. Well,
My
now
fault.
it's clear.
Okay.
Proposition 4. The congruence of figures is capable of making configurations influential more than knowability. And here, I read the line, the reasoning in this proposition is almost entirely physical. Okay. It is proved from the circumstances of the sublunary soul and also of the faculties of the human soul which perceive the aspects, okay, the configurations. These then are all inferior to the contemplative faculty and the understanding. and they have closer affinity with the sensitive faculty and the one which controls the operations of the senses. Indeed, the instinct of the former, as we have stated in chapter 3, is as much duller than the human instinct as the body of the earth is cruder than the body of man. But congruence is later in order than knowability and is, as it were, presented outwards to some operation which has the idea of the operations of the senses. It is therefore right for it to be believed that these animal faculties are moved and affected by congruence rather than by the knowability of the figures. And here we have a marvelous opposition between knowability from the soul and congruence here, not the congruence as object of the soul, but congruence as measure physically, as the noted mentioned.
Mm-hmm.
Congruence and knowability were therefore opposites in the same kind of configuration. Now two figures will be opposed to each other, first with reference to congruence alone, after that with reference to configurations. Okay, proposition 5. Congruence is a property of the figure at the circumference rather than at the center. Okay. Here, I think it's worth to read note 54. Here, the reasoning is entirely mathematical. Kepler asserts quite reasonably that the capacity to form congruences is a property of the figure as a whole, and the circumferential polygon is employed as a whole, the circle passing through all its vertices, whereas the central polygon has only one of its angle at the center. This difference enables Kepler to justify the use of the hierarchy of polygons defined in terms of congruence as a means of determining the relative status of the aspects once he had shown in proposition 6 that the circumferential polygon is more important in the determination of the aspect, and in proposition 7 that for the circumferential polygon, congruence is more important than knowability. Okay, I just reread the first two lines of proposition 5. Congruence is a property of the figure at the circumference rather than at the center, for it has the more important position in the figure, which can be whole on account of the position from which it takes its name, because congruence belongs to whole figures at its apparent from book 2. But of the central figure, not more than one angle can stand at the center by definition. However, at the circumference, the whole of the circumferential figure can exist. The proposition follows.
Sorry about that. Yeah.
Go ahead.
Just to hold in mind, what he's dealing with is a world that doesn't think of the quality that is shaping the quantities. So in astrology, in the astrological world, they pay a lot of interest to 20 degree, they'll measure the different aspects, and they'll look at the angle, the degrees, of different planets relative to the zodiac. But what is lacking is the sense of the quality that bounds all of these different numbers that the astrologers are looking at. And Kepler is trying to intervene, saying, no, what's more important than the angle from our perspective on the Earth looking at the stars is what is that higher organizing principle shaping the important singular aspects that would be in conjunction with certain changes which we would want to pay attention to in the sublunary nature. That's exactly. The more important thing, is the quality, not the quantity of the degrees per se.
You're right to have said that, because once again, principles and measure of phenomenal reality. And since I'm a little bit maniac on term of lexicon, let's not forget that knowability always has the meaning of epistemological journey. But in this case, you have to remember when you read congruence, that sometimes congruence means the higher congruence, meaning the harmonic proportions coming from the soul as a Platonic object, or in this case, as he precise with the note that it is about mathematical measure, congruence can also mean proportions as measured mathematically in the phenomenal reality, and not the congruence in terms of the soul, of the object of the soul.
Yeah, thank you.
Oh, I made that clear for you. Okay, so it was not
Well,
a
I'm
loss of
sorry.
time.
I was confused.
Okay, but you are forgiven now.
Yeah.
You're not no more confused.
Good. I see now.
So we we go to proposition 6. Of the two figures of which each aspect claims for itself that at the circumference is more important than that at the center. For congruence is more important in this business than knowability. But congruence is more important in the figure at the circumference. Hence, that which has superior power also makes the very thing in which it is have superior power. That is to say, the figure at the circumference. The same is also proved in the following way from the inmost properties of the soul, touched on in chapter 3. For as it is the soul which adapts its own formal essence to the harmonies of the configurations, certainly by the same distinction by which the soul is either a circle or a point which is the center of the circle, so also will the figures which belong to its household, those at the circumference and at the center, be distinguished. In fact, every soul bears some idea of a circle. In fact, of a circle abstracted not only from matter, but also in a sense from magnitude, as was stated in chapter 3. And so the circle and its center in this case almost coincide, and the soul is either a potential circle or a point in which directions are distinguished, and thus it can be said, in a sense, to have qualities. Yet it seems that the division must be observed between those faculties of the soul which should be considered rather as a circle, and those which should be considered rather as a point. For just as a circle cannot be imagined without a center, and on the other hand, every point has around it space for drawing a circle, so also in the case of the soul, there is no operation without an image forming impression. And on the other hand, every internal reception or meditation is on account of an external motion, and very interior faculty of the mind is on account of those which are rather exterior. What is the chief and supreme faculty of the soul? Called the mind, if not a center. What is the reasoning faculty, if not a circle? For just as the center is inside and the circle more outside, so the mind keeps itself to itself, and reasoning weaves a sort of exterior web. And just as the center is the basis, source, and origin of a circle, so the mind is of reasoning. Again, every such faculty of the soul, both the understanding, the contemplative, and indeed the sensitive faculty, are a sort of center. But the faculties of the soul which produce motion are a circle, because again, as a circle on the outside is placed about its center, so operation is towards the outside. And cognition and meditation are performed within. And as a circle is to a point, so in a way, external action is to internal contemplations, animate motion to sensation. For a point, because it is opposite to the circumference in all directions, is more suitable for representing passive experience, and for what is the sensitive soul, even as in this case, when it is that which perceives radiations, except for sensing and perceiving what it experiences passively, that is because it is moved by its objects. Also, by comparing each point of comparison, as the center is the same in either case, so also the form of cognition is in a way the same. The chief mental one and the sensitive or analogous to it, that which perceives radiations, neither uses contemplation in itself insofar as it is what it is, but it recognizes without contemplation. Hence, as the former, I mean sublunary nature or even the sensitive faculty, is a sort of faint image of the latter, the chief faculty of the human mind. So the former, contemplation by the reason, is an image of these actions and operations of the soul, a circle in each case. Therefore, insofar as souls perceive celestial radiations, and so far to speak, moved within themselves by them, let them be so far as points. But on the other hand, insofar as they are movers, that is, insofar as they transfer, perceive harmonies between the radiations into their own operations, and are stimulated by them to action, they should be considered as circle. It therefore follows that to the extent to which it is recognizing the harmonies of the rays, it is concerned chiefly with the central figure, whereas to the extent to which it is operating, arousing occurrences in the sky and similar ones in man, it fits itself to the one at the circumference. And in fact, in the case of an aspect, we give prior concern for its influence than for the means by which it is perceived by the operative soul, and therefore also prior attention to the figure at the circumference rather than to the figure at the center. In this case, figure was compared with figure in one and the same aspect. In the following couple, supposing the figure is the same, its congruence will be opposed to its knowability.
Excellent. Excellent. This is like I said, a very dense but very, I mean, I'm glad that we're reading this, because last week I had the stupid idea of thinking that people could just read this on their own, but I'm realizing no, this is an important thing to do this together. And maybe next week we might even continue with the propositions. I think it might be worth it. Yeah.
Proposition 6 is truly a poem to the soul.
Mm-hmm. It really
I was
is.
thinking the same thing. If I can write those last 6 propositions into some kind of poem or a short form, that would be amazing.
Absolutely. Well, it's a nicer way than my preaching half an hour ago when I say that you're responsible for your epistemological journey. I think that Kepler put it in a nicer way, which is a nicer preaching than mine.
That'll be all of our homework assignment for next week, is to take everything we read today and turn it into a poem.
Yeah.
My next week.
Yeah.
We'll see. We'll see.
Yeah.
We may not be there yet.
Yeah. Wow.
Like
this
sorry,
guy
Kepler, I'm sorry, he's talking about 3 or 4 things all at the same time. It's amazing.
Yeah, yeah. But let's not forget that when he was speaking of the central point, he was speaking of the supreme faculty of the soul, the mind, meaning the faculty of understanding. Okay. And when the mind at the center, okay, you imagine the compass, okay, with one tip at the center, and the compass would make the circle. And that circle, Kepler called that circle when speaking of the soul as the operative dimension of the soul. He calls the reasoning. Okay, when I said that he said in a nicer manner, my preaching that you are is responsible for your own epistemological journey. When you are at the center of your soul, meaning at the contemplative faculty and the supreme faculty of the soul, the mind, and that you make it active, that you will metaphorically, you would make the circle, meaning that you make it the soul active by going on the journey of reasoning or of epistemological journey, precisely.
Mm-hmm.
So, okay, so in his view, where does the heart come into play? Because I'm like, I mean, I just see a lot of people walking around in their heads and their intellect. They're not connected to their knowing or their soul or their heart. So I think when you say mind and the way Kepler uses mind, it's probably different than what people think about like just brain, right?
Exactly, exactly. You have to see his word mind as much richer than mind understood in modern neuropsychiatry and neurobiology, which is equal to intellect. Okay, but his mind is much richer than intellect.
Yeah. Yeah. Yeah, it's very integrated and mature. Like it's a healthy mind. Like
Yeah,
that's
it's a
not
healthy
detached from the
mind.
heart, you know. It's yeah, it's just healthier.
Yeah, exactly.
Yeah. Because his whole idea of mind, just like Plato's, is always vectored around the idea of the thing that the power that allows for the transformation of ignorance into knowledge, into truth. So what's that power of transformation? That's more what they're zeroing in on, which can never happen without love. Because if you don't love truth, then you can't move. You won't have the stamina to move from the unknown to the known, from the ignorant to the knowledge, because that takes work. It takes stumbling. It takes humility, self-examination to discover where you're wrong. Because nobody can just get the answer right away of something that they didn't know. It takes a few stumbles, like any baby learning to walk, right? But then that means you have to be aware of where your mental stumbles are, requiring thus humility and self-criticism. So all of these things are, which means you have to have like a lot of self-respect, which again, it gets you into this place that modern scientists don't like talking about because it's like icky, pollution of emotions and stuff. But no, it's all really, yeah, part of the same process.
Exactly. We don't create by a succession of axioms or of theorems. The succession of axiom or theorems are only the intellectual result that we can write in that manner if it pleases us. But I would say that this reading of Kepler is very interesting because even if he used axiom and proposition, it's not in the sense of the dry axioms and proposition in which you are prisoner, because under each proposition you have a depth of meaning that is not reduced to the Aristotelian canon. Okay, because I read the Aristotelian canon, and it's a way to make the mind poorer, and which is not bad per se, but you have to understand that the Aristotelian canon, the goal of it is to be precise and not to be creative. So there's nothing wrong to learn the Aristotelian canon as long as you know that the goal is to be precise in language and not to stimulate creativity.
Mm. Mm-hmm. Yeah. Well, yeah, it's more like getting into a verb-based relationship to reality, where you're looking at things not as if they just are these truths that are crystallized in definitions that you could memorize, but you're looking more at things from the standpoint, like we were talking about, of the circle. When you look at a circle, you don't just assume that there are these these circles, but that the circle is a shadow of an action that created the circle of rotation. That's what you're looking at, is like, what's the invisible creative process? Or when you're looking at a square, you're looking at, well, what brings the square into being from no square? So you're actually, whereas like somebody in an infantile state of mind would be like a child playing with blocks, pretending that the square is just these toys, or these cubes, or these blocks that you play with. But it's like, no, what brought it into being? How do you double a square? How do you create a triangle? Right? What is the process of creation? And that's always what you're looking for. And you're recognizing that your senses are showing you a shadow of an invisible but real generative process that you're always seeking.
Absolutely.
Yeah.
Yeah, that was beautiful.
Yeah. So I remind once again, I'm a little bit obsessed by lexicon. That what Kepler proposed is not bad. Okay, when he was speaking that to avoid confusion, either within the discussion of a group with bigger groups, Kepler used the word mind as the richest word for the soul, but at the same time, he proposed two expressions that are not object of confusion. That is the contemplative faculty of the mind, that is considered as a superior faculty of the soul. I'm sorry, the contemplative faculty of the soul, and the understanding faculty of the soul. Okay, with those two expressions, you will never be confused either in our small group or with bigger groups.
Yep. Cool. Well, all right. This was a edifying Wednesday evening as always. So what we'll do, I think we'll just pick up where we left off with Proposition 7 next week. I'm still always hungry to see different people's approaches to the Pythagorean theorem. So let's try to think about that. And also, if anybody along the way wants to come up with the side of the triangle and the side of the square and the side of the octagon, I'm always hungry for those two. And Nathan, send me an email of those pictures. And we can talk about that next week. All right, guys.
Okay. Ciao.
Till next week.
Wow.
Thank you.
Bye.
Thanks.